In this fifth module, AWS Elasticity and Management Tools, we're going to talk about the fundamental elements of the management tools themselves. Elastic Load Balancing, Autoscaling, and CloudWatch work as a triad in sync. Elastic Load Balancing and EC2 instances feed metrics to Amazon CloudWatch. Autoscaling defines a group with launch configurations and autoscaling policies. Amazon CloudWatch alarms execute autoscaling policies to affect the size of your fleet. All of these services work well individually, but together they become more powerful and increase the control and flexibility you demand. Understanding elastic load balancing includes concepts around our classic load balancer, our application load balancer, and comparing the two. Elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve greater fault tolerance in your applications and seamlessly provide the amount of load balancing capacity needed in response to incoming application traffic. Elastic load balancing detects unhealthy instances within a pool and automatically reroutes traffic to healthy instances until the unhealthy instances have been restored. You can enable elastic load balancing within a single availability zone or across multiple zones for even more consistent application performance. You can access and work with your load balancer using one of the following interfaces. AWS Management Console. This is a simple web browser interface that you use to create and manage your load balancers without using additional software or tools. Command line interfaces. A Java-based command line client wraps around the SOAP API. AWS SDKs. Language-specific APIs that take care of many of the connection details, such as calculating signatures, handling request retries, and error handling. Query APIs. These are low-level API actions that you can call using HTTPS requests. Back to the top. A load balancer distributes incoming application traffic across multiple EC2 instances in multiple availability zones. This increases the fault tolerance of your applications. Elastic load balancing detects unhealthy instances and routes traffic only to healthy instances. Your load balancer serves as a single point of contact for clients. This increases the availability of your application. You can add and remove instances from your load balancer as your needs change without disrupting the overall flow of requests to your application. Elastic load balancing scales as traffic to your application changes over time. Elastic load balancing can scale to the vast majority of workloads automatically. A listener checks for connection requests from clients using the protocol and port that you configure. It, in turn, forwards requests to one or more registered instances using a port and protocol also that you configure. You add one or more listeners to your load balancer. You can configure health checks, which are used to monitor the health of registered instances so that the load balancer can send requests only to the healthy instances. By default, the load balancer distributes traffic evenly across availability zones that you enable for your load balancer. To distribute traffic evenly across all registered instances in all availability zones, enable cross-zone load balancing on your load balancer. An application load balancer, ALB, functions at the application layer, layer 7 of the OSI model. The ALB makes routing decisions based on the content of the application traffic in the HTTP message. With ALB, we require you to enable multiple availability zones. A load balancer serves as the single point of contact for clients. You add one or more listeners to your load balancer. A listener checks for connection requests from clients using the protocol and port that you configure and forwards requests to one or more target groups based on the rules that you define. Each rule specifies a target group, condition, and priority. When the condition is met, the traffic is forwarded to the target group. You must define a default rule for each listener, and you can add rules that specify different target groups based on the content of the request. This is also known as content-based routing. Each target group routes requests to one or more registered targets, such as EC2 instances, using the protocol and port number that you specify. You can register a target with multiple target groups. You can configure health checks on a per target group basis. Health checks are performed on all targets registered to a target group that is specified in a listener rule for your load balancer. This slide shows the basic components of an automatic or application load balancer. Each listener contains a default rule, and one listener contains another rule that routes requests to a different target group. One target is registered with two target groups. The listener on the right has been configured with a rule to route API requests to one target and mobile requests to another. Application load balancing access laws contain additional information that are stored in compressed format, and ALB has improved load balancer performance. Amazon CloudWatch lets you view graphs, set alarms to troubleshoot, spot trends, and take automated action based on the state. It is accessible via the AWS Management Console, APIs, SDKs, or CLI. You can customize with your own metrics or use a sample template found online. For Amazon EC2 instances, Amazon CloudWatch Basic Monitoring collects and reports metrics for CPU utilization, data transfer, and disk usage activity from each Amazon EC2 instance at 5-minute increments. Amazon CloudWatch Detailed Monitoring provides these same metrics at 1-minute intervals and also enables data aggregation by Amazon EC2 AMI ID and instance type. Set alarm on any of your metrics to receive notifications. You can also use auto-scaling to add or remove Amazon instances. Amazon CloudWatch is a metrics repository. AWS products put metrics into the repository, and you retrieve statistics based on the metrics. Statistics can be graphically presented in the CloudWatch console. This slide shows screenshots from the Amazon CloudWatch console. In the example, a user has selected an EC2 per instance metric of CPU utilization. Auto-scaling concepts include launch configurations, auto-scaling groups, scaling plans, auto-scaling life cycles, and auto-scaling limits. Auto-scaling helps you ensure that you have the correct number of EC2 instances available to handle the load for your application. Auto-scaling is particularly well suited for applications that experience hourly, daily, or weekly variability in usage. Adding auto-scaling to your application architecture is one way to maximize the benefits of the AWS cloud. When you use auto-scaling, your applications gain the following benefits. First, they have better fault tolerance. Auto-scaling can detect when an instance is unhealthy, terminate it, and launch an instance to replace it. You can also configure auto-scaling to use multiple availability zones. If one availability zone becomes unavailable, auto-scaling can launch instances in another one to compensate. Next, you can get better availability. Auto-scaling can help you ensure that your application always has the right amount of capacity to handle the current traffic demands. Third, better cost management. Auto-scaling can dynamically increase and decrease capacity as needed. Because you pay for the EC2 instances you use, you save money by launching instances when they're actually needed and terminating them when they're not needed. When you create an auto-scaling group, you must specify a launch configuration. You can specify your launch configuration with multiple auto-scaling groups. However, you can only specify one launch configuration for an auto-scaling group at a time, and you cannot modify a launch configuration after you've created it. If you want to change the launch configuration for your auto-scaling group, you must create a new launch configuration and then update your auto-scaling group with that new launch configuration. When you change the launch configuration for your auto-scaling group, any new instances launched are using the new configuration parameters, but existing instances are not affected. You can create collections of EC2 instances called auto-scaling groups. You can specify the minimum number of instances in each auto-scaling group, and auto-scaling ensures that your group never goes below this size. You can specify the maximum number of instances in each auto-scaling group, and auto-scaling ensures that your group never goes above this size. If you specify the desired capacity, either when you create the group or any time thereafter, auto-scaling ensures that your group has this many instances. If you specify scaling policies, auto-scaling can launch or terminate instances as demand on your application increases or decreases. Each CloudWatch alarm watches a single metric and sends messages to auto-scaling when the metric breaches a threshold that you specify in your policy. You can create a scaling policy that uses CloudWatch to determine when your auto-scaling group should scale out or scale in, and you can use alarms to monitor any of the metrics that AWS services send to Amazon CloudWatch. Auto-scaling basic lifecycle. This scaling group has a desired capacity of 3 instances. A CloudWatch alarm triggers a scaling event, and policies scale the group at a specific date and time. The scaling policy launches an instance and attaches it to the auto-scaling group. A health check fails and triggers an alarm similar to scaling out, and the instance is then detached from the auto-scaling group. AWS Trusted Advisor provides AWS customers with performance and security recommendations in 4 categories: cost optimization, security, fault tolerance, and performance improvement. They will have one of 3 status checks: red saying action recommended, yellow requesting investigation, and green with no problem detected. For each check, you can review a detailed description of the recommended best practice, a set of the alert criteria, guidelines for action, and a list of useful resources on the topic. AWS Trusted Advisor helps you save money on AWS by checking for unused and idle resources and making commitments for reserved capacity. AWS Trusted Advisor helps you improve the security of your application by closing gaps, enabling various AWS security features, and examining your permissions. AWS Trusted Advisor helps you increase the availability and redundancy of your AWS applications by taking advantage of auto-scaling, health checks, multi-AZ, and backup capabilities. Finally, AWS Trusted Advisor helps you improve the performance of your service by checking your service limits, ensuring that you take advantage of provision throughput, and monitoring for overutilized instances.